Hey, what's up, everybody? My name is Lawrence Green. I am doing the tight junctions. So as soon as I get everything up and running, we can get started. So basically, page 2 is the overview and general information. Page 3 is the structure. Page 4 is location, specific organisms. 5 is disease associated with malfunction and recent finding on tight junctions. Page 6 and page 7 is questions. General information about tight junction is their junctions form a regulated barrier to a paracellular transport of solutes and ions. They're a multi-protein junctional complex, and ideally they're here to prevent leakage between solutes, water, and seals in the paracellular pathway. But at the same time, there are barriers that are set up in the aqueous channels that are capable of discriminating based off charge and size. The proteins that are included are claudines and occludines. Claudine family are arranged between 1 and 2, which are small integral proteins. They create a selective paracellular properties. Specifically, some key points are proteins 1 through 8, which bind to the ZO1, 2, and 3. Other proteins, occludine, which is an integral protein that copolymerizes with the claudine polymers, which here I've added like a little picture of the structure down on the bottom right, which show the solute molecules and the tight junction membrane proteins that sit between the lipid bilayer and the cytoplasm. Get a text here, sorry. The location and function. I got a graph right here. It just kind of shows you like the location and where they kind of sit within respect to the mucosal layer, the apical side, and the basolateral surface. There's some key functions here. They hold cells together. They have a barrier function, which are for the purpose of material transport and osmotic balance. They maintain polarity of cells by preventing lateral diffusion. And they prevent the passage of molecules, ions through the space between the plasma membranes and adjacent cells. Disease associated with tight membranes are leukocyte adhesion deficiency, blood-brain barrier, and cirrhosis. So just kind of real quick, blood-brain barrier affect individuals who are unable to produce B2 subunit of the integrin. So what happens is you get blood-brain bacterial infections, which they can cross that blood-brain barrier and get into the nervous system or into the blood. So you want to kind of be wary of that. And so one of those is leukocyte adhesion deficiency. Like I said, blood-brain barrier, which I highlighted where the edema forms as a result of a leaky blood tumor barrier and persists when the brain fails to clear excess fluid, which can lead to death. The common property of brain tumor is their ability to cause edema in the surrounding brain tissue. Cirrhosis is where a tight junction of biliary epithelial cells and hepatocytes prevent bile regurgitation, which lead to chronic cholestic liver disease and primary cirrhosis and sclerosing cholangitis, which I'm not real sure what that is, to be honest. Primary research or targets of infectious diseases. Tight junction transmembrane proteins are the most exposed intracellular junctions components that pathogens encounter during their interactions with host cells. Some common ones are hepatitis C virus, which are pathogens that use the claudine transmembrane proteins as receptors for internalization. The reovirus, which prevent infectious agents in children, which cause respiratory and gastro or GI disease. The last one is Coxsackie viruses, which are causative agents of meningitis and myocarditis. And I got a graph there for you as well to kind of just show you the flow and where these viruses attack in that membrane. Question of the day: what are 5 characteristics of tight junctions? Boom. Let me know. Okay. Bye-bye.